Hello everyone and welcome back. So this time we're going to be learning about power and efficiency. Very important concepts. Okay, so what is power? Power is probably the simplest concept we're going to get to this entire time. Power is simply energy over time. Energy over time. If you can calculate the energy and you can figure out how long it was going, you know power. That's it. E over T. You're done. It has one unit that's used. It's the watt. There's also horsepower here, but that's not really used as much except for in cars. But the watt, and the watt is equal to 1 joule per second. 1 joule per second. Okay, so with that incredibly easy concept out of the way, let's talk about efficiency. What is efficiency? Well, efficiency is a ratio because let's say that you have a motor. It's an electric motor. You put electrical power into that motor, and then that motor does work. Electrical power in does work. However, all the power you put in does not actually make it to doing work. Only a certain amount, a fraction of it does. If it's a good motor, it might be 95, 96%. If it's a bad motor, it might be 50. And at least for cars, there is a certain max efficiency they can have. So that ratio is the efficiency. It's got always with a Greek letter. It looks like an N. It's an eta. And it's energy out over energy in, or power out over power in. So if you have, somebody doing something, and there's an energy before and an energy after, you might be able to figure out efficiency there. This comes in really common when you see like motors or collisions. You want to figure out how efficient it was. So for example, if I put in 50 watts into an engine and it's 0.5 is its efficiency, well then 25 watts will come out. That's it. Only 25 watts actually makes it to doing work. I used to teach electrical concepts in this class. It's just too much to put into one semester, and so I didn't. But that really gets connected there. We have an electrical motor. You have to figure out, well, what power went in, what power came out, and therefore what's the efficiency of the motor. It's still cool stuff though. And if you want to read that, I think it's the end of the chapter 8 that has that. A lot of interesting information there. Okay, power in, power out. That's efficiency. Don't forget that. It's incredibly important. Now, while we're at it, let's go ahead and finish this up. So, how things connect. As you might have seen by all those equations, it connects everywhere. Mass, velocity, temperature, force, weight, they're all in the equations. So honestly, you just have to think about what is the problem asking. If something's getting lifted, then it's probably the potential energy equation you need. If you have a velocity, then it's almost always kinetic energy. If you are pushing things, and I'm not talking about lifting things, that's kind of a push, mostly like along the ground pushing things, it's probably work. And if you're hitting things up, well, it's thermal. So there's all these different types of energy, and you have to choose which one. You will get better at this. I'll be trying to do an example problem for each of these, at least as much as I can. And you should hopefully be able to see, as you go through it, oh, that's kinetic. Oh, that's thermal. Oh, that's not energy at all. That's recipe for cookies. Okay, my toddler laughed. Okay, the last thing, let's talk about units. How do you convert units? It's all super simple. It's in your conversion sheet. A joule is a Newton meter, so if you have Newton meters, that's joules. You don't have to do anything. It's just 1 to 1. But the other kind of common unit is the foot-pound. You see this in torque too. Don't get them confused. But the foot-pound is another one, and it's just a fraction of a joule. So 0.7375 foot-pounds is equal to 1 joule. If I multiply everything together, I get 331.875 foot-pounds equal to 450 joules. I could have done that in 2 steps because remember a joule is a Newton meter, and therefore I could have converted newtons to pounds, pound force, not pound mass. Be very careful about that. And meters to feet, and everything would have been fine there. Don't do that. Extra steps lead to extra mistakes. Why make extra mistakes? You don't need to. So, with that, we've finished up energy and power. That seemed to go fast. I'm going to have some example problems for you, so go through those videos as well, because you need to see these equations being used. So I hope this helped you. This is actually the last of the physical concepts that are covered in this class. So if you're watching this video, pretty much done it. Well done. I'll see all of you next time. Bye-bye.